And we're finally to partial fraction decomposition. So for our partial fraction decomposition, we're working on the first and the last steps here. We're missing sort of the actual algebra, the partial fraction decomposition. I did that in a separate question. So I'm going to do A and B, 9 and 10 together here because I think they'll both be pretty quick. These are all about recognizing the different forms for partial fraction decomposition in A. We do have some that have, the second one has been factored for us, but we do need to factor the other two. So here in the top, we end up with x minus 5 squared, which means we have repeated linears. So we'd have to recognize that we need an a over x minus 5 plus a b over x minus 5 squared. Bring back your integral symbol and your dx because there is an equal to sign here, and we want to make sure that we are writing down something that is equivalent. Next one was actually done for us in terms of the factoring. So we have a repeated linear, which as we learned, we can also treat as an irreducible quad, either way. And we have a repeated irreducible quadratic with that sum of squares. So however you want to set that up, as we noted, I'm going to go ahead and treat it as a repeated linear. So we have a over x over b over x squared plus cx plus d over the first instance of this repeated quadratic factor. I guess I don't need parentheses here. And then we'll need one more, e to the x plus f all over that x squared plus 1 squared. All right, so that was the correct answer for the second one. As noted, completely okay if you had an ax plus b over that x squared in that particular first set, because it turns out that simplifies back down to what we have written there. That would have been okay as well. I'll go ahead and write the whole thing so that we have it here, because not everyone will watch these videos. Whoop, whoop. There we go. Those are both okay. Okay, so let's look at the last one. I need my green pen back. This one is not factored, so again, we have to do a little factoring. We see we have an x. Oh, that was not that exciting. Just a linear. It's actually so easy after the last one. I'm kind of annoyed with myself for the order of those. Is looking back at past me's work, sometimes I'm just like, what was she doing? So we have an ax plus bx plus c all over that x squared plus 4. So a much simpler problem after the 1 and 4 before it, except for that you had a little factoring to do on the onset. So that's step 1 of partial fraction decomposition. We should be good at it. And then step 2 is once you have your partial fraction, well, it's usually partial fraction, but then step 3 is once you have them to actually take an antiderivative. And so all these problems below are set up as if we've already done the partial fraction decomposition and just verifying that you know what to do once you get to that final result. So this, we have 2 linear bits. Look at that. You might want to rewrite this one as 5/3 over x plus 7. Right? Because that is a much nicer way to look at this. We know that if we did a u sub with x plus 7, it's not going to impact anything because there is a slope of 1, or the derivative over x plus 7 is just dx. There's no need to do any sort of fix to anything. And on the back half, unfortunately, we have, I mean, you guess you could make that, you could factor out the 2/3 and make it an x plus 1/2. That's not wrong. That would work. So if you wanted to, you could make it. I guess you could do that. This is what I'm doing in my brain. Like, it could be this. But then you have fractions and fractions, which is, fractionception, which is not great. But this does have, right? This one will be a problem in terms of u sub. We need to deal with the fact that if we were to chain rule something that has a 2x plus 1, we're going to be multiplying by 2. I am, of course, not going to set that up because I refuse to do that. We are past that. So I'm just going to write out the answer here. We have 3 ln of that entire denominator. We know that if we took the derivative of this, there'd be an extra times 2. So we'll go ahead and divide by 2 instead of doing u sub. And then we have a minus 5/3 ln of x plus 7. Boom. All right. B is really making sure that you understand that repeated linear factors do not mean just a butt ton of ln's. When they're repeated, now we need u sub in the other sense of it, right? This is going to be 2u plus 3u to the negative 1 plus 4u to the negative 3. The only one that has an ln as the antiderivative is the single instance of our linear factor in our denominator. The rest are going to be power rule. So this answer here, the antiderivative is going to be 2 ln of x minus 2 plus 3. This one is going to be x minus 2 instead of to the negative 1. Of negative 2, it's going to be negative 1. And then we divide by a negative 1. So let's just change that to a minus. The next one, we're going to have our x minus 2 to the negative 2. And then we're going to divide by a negative 2. So I'll have a minus 2. 4 divided by negative 2 is negative 2 plus c. You could stop here. Or if you want to be, you could do a little bit of this action, so it kind of looks more like our original problem. Generally, it's kind of nice to get things back in the format they were given to you. Just shows that you care. And then we have our last one, which is really where I wanted to see that we understood how to handle those irreducible quadratics. So first two terms, straightforward, right? In fact, I'll go ahead and start writing my answer right now. ln of x. This one's a baby power rule, so it's going to be minus 2 over x, right? This would be x to the negative 2. You get the whole idea. And the question is just, WTF is happening with this piece? And as we discussed in class, the smartest thing to do here is to break this into two different terms. One where the linear factor is on the top, or the linear term is on top of the numerator, and one where we have the brain is processing slowly, the constant. The reasoning here is that this one that we have on the right, this is just going to be arctan, right? You might have to do a little bit of work with the arctan in terms of using that antiderivative, but that's it. The one on the left, we are going to have to do a baby u sub, right? So u is equal to x squared plus 1, du is equal to 2x. We need to do a little adjustment, but we end up with a negative 3 over 2 ln of that x squared plus 1. So those two pieces are treated very differently, and I wanted to see that we knew how to do those things. So we have a minus 3 halves ln of x squared plus 1 and a minus 2 arctan of x plus c. So there's our final answer to that particular problem.